All right, so let's take a look at our lesson for today. We are going to explore trigonometric identities another day. This is where we're doing proofs. I'm going to remind you some of the things we talked about last time. One being that we're only allowed to work on one side of the equal sign. You get to pick which one you want to do, but it's only one side. Okay, we can't work both sides. And the other thing is we really need to write a reason for each of our steps. There's a couple of reasons for that. One is that it helps you organize your work and it helps you kind of internalize the steps that you're taking. Another reason is so I can follow your work. I mean, that's also a reason too. So I could tell what it is that you're doing. All right, so let's go ahead and start with number one. As I look at both of these sides, there really doesn't seem to be a clear answer on which one I want to start on. They both are fractions, you know, they both have like a binomial and a monomial. So what I decided that I wanted to do was I decided to work on the left side, and the reason being really is just I wanted to take this 1 plus cosine and multiply this whole side by 1 minus cosine over 1 minus cosine, so I could get rid of the plus in the bottom. So what we're going to do is we're going to work on the left side, and this right side is our goal. That's where we're going. That's what we need to kind of keep in mind as we're working. So let's start. So I'm going to take our left side. I'm going to multiply it by 1 minus cosine over 1 minus cosine. And again, I think it's real handy to put RHS, or right hand side or left hand side, because that actually also helps you to not even be tempted to try to mess with the other side. We're not allowed to mess with it anyway, so that really, I think, helps take that temptation away. So this reason would be, we're just going to be multiplying by 1. Okay, so let's go ahead. I'm actually not going to distribute the numerator, just in case something fun pops up. I don't really know whether it will or not. Well, we'll try. But I do need to distribute the denominator because that's conjugates. Remember, conjugates are quite helpful because they eliminate the middle term. So 1 times 1 is 1. Outside, inside goes away. Cosine times negative cosine is negative cosine squared. And all we did here was just multiply. We just multiplied. Now what we want to do is we want to step back and look at what we have, look at where we're going. The denominator of 1 minus cosine squared should kind of have warning bells, or like little bells going off in your brain. We should recognize that at this point. Do we know what 1 minus cosine squared is equivalent to? Sine squared. Very nice. It's equivalent to sine squared. That's one of the Pythagorean identities. So since I need a sign in the denominator anyway, that's what I'm going to do. Everything we do is for a reason. I'm going to leave the numerator alone. Just leave that alone. And the denominator, I'm going to use that Pythagorean identity and change 1 minus cosine squared to be sine squared. And here, the reason I just did the Pythagorean identity, so Pythag is my reason. All right, so look at what we have and where we're going. Oh goodness, we're very close. If you'll see, this part right here matches 1 minus cosine. That's good. We want to leave that part. What we have left over is sine over sine squared. And can we see what was in store for us there? Does that kind of... We can, right? So I can cancel one of the sign in the numerator with one of the signs in the denominator. So let's do that. So the sign in the numerator is gone, and one of the signs in the denominator is gone. And I actually have arrived to where I wanted to, and I'm just going to, and you can just put RHS. You don't have to copy this over. So we canceled. Okay. And that's our first one for today. Are we doing okay? Yes? Any questions? Okay. Let's navigate to our second one. So on this one, gosh, it looks, this second side, this left-hand side right here is gigantic. I mean, I I would much rather try to whittle that down than to take this and make it bigger, you know. So I'm actually going to choose to work on the left-hand side. And I know it's kind of weird. I think maybe even all the ones I'm doing today were working on the left-hand side. That just is coincidental. It doesn't mean that we always work the left-hand side. It just so happens that's the way that they were written out. So let's see. So we need to get to a cosecant. Interestingly enough, we already have a cosecant over here. That's kind of interesting. So let's focus our attention on the other things up there. So I've got a cosine squared, and I know, you know, and a sine, and it really would be a good idea to narrow down or make fewer different trig functions. So I think that I would like to do is take the cosine squared and use the Pythagorean identity to turn it into 1 minus sine squared. That's just going to help me. It's going to help me to get, I just have all sines and cosecants, and that certainly is going to help me go forward somehow. We don't know how yet, but this is just a work in progress. We don't need to know exactly how to get to every step before we start. We just start somewhere and we just keep moving. So cosine squared is 1 minus sine squared, and then plus sine equals right-hand side, and this is Pythag. Okay, and I'm still focusing on that right-hand side. It's just a plain old cosecant. So I don't have any parentheses on the right-hand side, so it would probably be a good idea to get rid of the parentheses. So I'm going to distribute the cosecant. And so I'm going to get cosecant times 1 is cosecant. Cosecant times sine squared is cosecant sine squared plus sine equals right-hand side, and here I just multiplied. You could say multiply or distribute, whichever word you like better. Okay, so let's pause here for a second. My eye is kind of drawn to that middle term, that really weird cosecant sine squared. I kind of want to focus on doing something with that one. Let's see, so let's think about cosecant. And let's think about a reciprocal identity associated with cosecant. What is cosecant equivalent to? What's its reciprocal identity? 1 over sine. So why don't we do that? Why don't we do the reciprocal identity and see if that helps us out any? As we have talked about before, as long as you don't make a trig mistake or an algebra mistake, you can't go wrong. I mean, it may take you more steps than someone else, but it doesn't really matter. All right, so that is reciprocal.
Why wouldn't you do like the 1 over sine to the other cosecant?
Oh, good question. So we could do the 1 over sine to the other cosecant, but I'm holding out hope. I'm holding out hope that this is going to match this up here. I'm hoping that these two other things are going to disappear. I don't know if they are, but I need to keep a cosecant because my answer is supposed to be cosecant. Does that make sense? Yeah, that's what I'm trying for. Now, you don't, certainly if that's a problem, you could turn it and then turn it back. I mean, it'd be fine. And I may have false hope. I don't know. We'll see. Hopefully it will end up being correct, but it may not. All right, so here in the middle, I've got my sine squared, 1 minus sine. I can simplify that, can't I? Because that's like sine squared over sine. So let's rewrite this out. So sine squared over sine just leaves me 1 sine. And I just cancel. I cancel the sine from, goodness, can't spell. I cancel the sine from the numerator to the denominator. Okay, so how are we doing now? We see what we can do next? Right, we can just combine those like terms and they disappear. So I now have cosecant is equal to cosecant, and this would be, we could call it subtracting, because we basically subtracted sine minus sine and got 0, and we're there. How is that? Okay. We have 2 more proofs to work on. Let's get to our second page. And while I'm working them, I'm trying to kind of talk through with you when I look at a proof, the things that I think of, the things that I would like for you to think of. As we look at number 3, I'm looking at the left side and the right side, and I have to ask myself, do I want to get rid of a plus, or do I want to get rid of a multiplication? We just have to make that decision. What do we think would be easier for ourselves? I thought it would be easier to get rid of a plus, because I can make a fraction, I can add them together. You know, that was my thinking, and so I went with working on the left side, but maybe the right side would have been better, trying to figure out how to get a plus in there. I don't know. To me, it's easier to get rid of a plus than a multiplication, so that's why I chose the left-hand side. So let's see, cotangent and tangent. Why don't we go ahead and do like quotient rule on both of those? Let's just turn them into sines and cosines and see how, if we can make some heads or tails of it. Again, there's many different ways, many different paths to get to the same conclusion. So this is just something that I would think. You might think something completely different, and that's perfectly fine. So cotangent is cosine over sine, and tangent is sine over cosine, and bizarrely enough, we're doing right-hand side again, and we use quotient identity to do that. So with the fractions, we want to find a common denominator and add them together. That's kind of how we get rid of the plus. So what I'm going to do is I'm going to multiply this first one by cosine over cosine. And then I'm going to multiply the second one by sine over sine. What I'm doing is I'm finding a common denominator. Okay, and that's the right-hand side. And I'm just going to say, I could say common denominator. I could say multiply by 1. I mean, I've got lots of options. Let's just say multiply by 1. Either one is fine. So let's do that. Let's multiply that all out. So cosine times cosine is cosine squared. Cosine times sine is simply cosine times sine. Sine times sine is sine squared. And then cosine times sine is just, cosine times sine. And here I just multiplied it. Okay. So let's kind of highlight where we're going. We're trying to get here. Okay, just keep the end goal in mind. So now I have two fractions that have a common denominator. I can actually add them together. And so let's do that. So I have cosine squared plus sine squared over cosine sine. And this is just adding. I just added fractions. Okay, so we're making progress, Does anyone see like some identity that's just kind of jumping out at you? What, huh? Yep, cosine squared plus sine squared is 1. Exactly. So why don't we use that Pythagorean identity? Let's get rid of that cosine squared plus sine squared. So I have 1 over cosine times sine. Very nice, and that would be Pythag. Okay, we're getting there. Is there a relationship between 1 over cosine and 1 over sine with cosecant and secant? Is there a relationship there? Yeah, reciprocal, right? The reciprocal identity is what's going to help us there. So if we do reciprocal, 1 over cosine is secant, and 1 over sine is cosecant. And that's reciprocal identity. And if it troubles you that they're in the reversed order, you can just change them. Multiplying 2 times 3 is the same as 3 times 2. So if that bothers you, we can just switch them, be fine. And we made our way to the end. Okay, how are we doing? Okay. one more to do together. So let's move to our last one. Goodness, this one, I mean, certainly I'm going to work on the left-hand side. That's a big mess, right? There's a bunch going on over here. The right-hand side looks so easy. Right? There's no way I want to try to turn 2 cosecant to 2 things that are adding to each other. That seems like way too hard. So I'm going to work on the left side. So when we have 2 fractions, and we don't need, so as I look at the right side, it's 2 cosecant. I look at the left side, I have 2 fractions that are added. I mean, I'm going to have to add them together, right? I can't have 2 fractions turn into cosecant, so 2 cosecant. So I need a common denominator. So let's do the common denominator thing. So I'm going to multiply this first one by sine over sine. And the second one, I'm going to multiply by 1 plus cosine over 1 plus cosine, and all of this is to get our common denominator. So we'll call this multiply by 1. I'm going to leave, I'm not going to actually multiply the denominators together. I'm going to leave them separate just in case something turns up fun that I can do with them. But I certainly am going to have to multiply the numerators together. So sine times sine is sine squared over sine times 1 plus cosine. And 1 plus cosine times 1 plus cosine, that's foiling. I hope we remember that that's foiling. So that would be 1 plus cosine plus cosine plus cosine squared. And we're going to leave the denominator factored. Let's not distribute yet. Okay, and so all we did here is we multiplied. Okay, I'm going to pause here for a moment. So all we're doing is cleaning up, multiplying out the numerators. Okay, what do we think our next step is going to be? Now we have common denominators. What might we do? Yeah, add the fractions together. Let's add the fractions together. So I've got sine squared plus 1 plus, and I'm going to do cosine plus cosine is 2 cosine plus cosine squared all over sine x times 1 plus cosine x. And we just added fractions. That's all we did. So we step back at this, we kind of take a look at what's going on. We're looking for maybe an identity to pop out at us, some kind of a clue. Does anybody see something in the numerator that might be helpful? Anybody see anything? Yes, ma'am?
There's the sine squared x plus cosine squared x.
Absolutely.
There's 1 plus 2 cosine.
Yeah, they're going to be, so sine squared plus cosine squared is 1. Now, they're separate from each other, but that doesn't really matter. It makes it harder to realize that's true, but it's okay, right? I can take, so this sine squared plus this cosine squared gives me a 1. So I have 1 plus 2 cosine x over sine times 1 plus cosine. And this was Pythag. Okay. We can add 1 plus 1, right? Whoever knew 1 plus 1 was so hard. It's right here in the middle here. 1 plus 1. We can do that. So that's 2 plus 2 cosine over sine times 1 plus cosine equals RHS. We just added. Okay, so now you want to step back from this and take a look. I've got a 1, so I shouldn't have any pluses at all, right? I've got a 1 plus cosine in the bottom. Why shouldn't I have any pluses? Because this guy right here doesn't have any pluses. It's just 2 cosecant. can we kind of investigate, how could we get rid of the 1 plus cosine? Does anybody see anything that we can do to the numerator to help us? Uh-huh.
Can you factor out the 2?
Absolutely. That's a fantastic idea. Let's factor out the 2. Okay, so we're going to factor out the 2. And that leaves us 1 plus cosine over sine times 1 plus cosine. Oh goodness, this is getting exciting. We're getting close. And this is factoring. That's what we just did, is factor. Okay. And now we should, do we see what to do now? This is just kind of jumping out at us, right? Cancel. We should cancel. So we're going to cancel those 2. And we're going to be left with 2 over sine equals the right-hand side, and that's cancel. Oh my goodness, we're so close. We need to be 2 cosecant. Are sine and cosecant related? They are, aren't they? 1 over sine is the same thing as what? Cosecant. 1 over sine, so 2 over sine is 2, okay, just 2 cosecant equals 2 cosecant, and that was reciprocal property. Okay.